All right, section 5.5. This is the last section that we're going to cover in this class, and it's on u-substitution. Now, if you go on to take Calculus 2, you're going to learn a lot of different techniques of integration, and this is the first one. So far, all the rules that we've learned for taking integrals or antiderivatives have essentially just been a derivative rule that we were using in reverse. And this is not really any different. U-substitution is what lets us undo the chain rule. Now, suppose you were asked to do these two integrals here. These are not things that we've learned how to deal with yet, but if you looked at them long enough, you might realize that they look like derivatives that were obtained using the chain rule. What do I mean by that? Well, this one right here, you got an x squared here, and it's nested inside of something, and its derivative shows up over here. So this first one, you might be able to come up with, this is sine x squared plus c. Why? Because if you take the derivative of this, derivative of sine x squared would be cosine x squared, and then chain rule says multiply by 2x, which is what we've got up here. This other one's probably a little trickier, but you might notice that this is x cubed squared, and this up here is the derivative of x cubed. And so this would give you arctan of x cubed plus c. Because if you took the derivative of arctan of 1 plus x cubed, you get 1 over 1 plus whatever squared. This would be x cubed. That would give you x to the 6th. And then by the chain rule, you'd have to multiply by 3x squared. So anyway, these are two things that you could do, you could evaluate by undoing the chain rule. But as I say right here, that's not a method. What we need is a method for dealing with these kinds of problems. So let's talk about u-sub. U is a function of x, and u-substitution lets us do integrals of this form here. F of u times u prime. And I probably should have thrown a little constant in here as well. But you've got f of u times u prime times a constant and then dx. And if you look up here, both of these sort of satisfy that. Notice what's going on. The important thing is the function, or u shows up nested inside of some other function. U's derivative shows up multiplied by that. And that's what's going on up here. X squared is my u on this one. My du, well, the derivative of that is going to be 2x. So I've got cosine of x squared, and then I've got 2x dx there, which that's what you get if you multiply the dx on both sides. So that's the thing that tips us off that we could use u-substitution there. So we've got a set of sort of steps that we would take to do u-substitution. Now, I don't want to read through all those steps because I don't think reading through them is going to be useful until we look at an example. So let's look at the first example while we do that. Better yet, well, yeah, we'll look at this first example. When you look at this, first off, find your u. Notice it says find u. U is nested inside another function, and also u's derivative shows up somewhere. So if you look at this, 1 minus x to the 4th, that's nested inside of this squared function. And its derivative, I'm just going to write this as the differential. It's minus 4x cubed dx. That dx is important. And remember, this is just like saying du dx is equal to that, and then multiplying both sides by dx. So this is what we've got. Okay, the next thing I want to do is solve this for dx. Dx then is du over minus 4x cubed. I'm going to put that in a box because that's all my substitution stuff. Now I'm going to come over here and I'm going to rewrite the integral. Now everything that's over here has to show up in my new integral. So I've got x cubed. Then I've got this right here. I'm going to rewrite that as u squared. Then I'm going to replace the dx with this. All right, now that I've done that, I can cancel some x's. X cubed and x cubed. So what I'm left with is integral of negative 1/4 u squared du. Now notice what's happened here. I've taken it from an integral that only had x's in it, and then by doing this, I've changed it to an integral that only has u's in it. So now I can just integrate this as an integral with u as its variable. So I get minus 1/4 times 1/3 u cubed plus c. And of course that's minus 1/12 u cubed plus c. And then the last step, don't forget to do this, put it back in terms of x. So u is equal to 1 minus x to the 4th. So my last step is going to be to rewrite this as minus 1/12, 1 minus x to the 4th cubed plus c. And that's it. Now, if you wanted to, you could take the derivative of this to check it. And the derivative should give you exactly this. All right, let's do another example. On this one, here's my inside function. It's nested inside of the cosine, and so I'll let u equal x squared plus x plus 1. So du is going to be the derivative of that times dx. And I'm actually not going to do the step here where I solve for dx. That step's not always necessary. Reason is, inside of here again, I want to make sure everything over here makes it into my new integral. Now, the cosine x squared plus x plus 1, that just gets replaced with cosine of u. And then the 2x plus 1 times dx, that just gets replaced with dx. And so now I've completely, I'm sorry, it gets replaced with du, not dx. And so now I've got a new integral that's all in terms of u. When I integrate it, I get integral of cosine, remember, is positive sine. So I get sine of u plus c. Then my last step is to rewrite it as sine of x squared plus x plus 1 plus c. All right. Now, I've got a bunch of examples here, but I think what I want to do is split these examples up into probably two additional videos of examples before we look at definite integrals. So this video will stop here.